see. Okay, so in this case, if I put in now y equals, and then I had x, and then not sure how I'm supposed to do the squared and that. Did I go like that? Oh, okay, x squared, and then I have it was plus 3x plus 2x. Okay. Let's see, I gotta push more like this. Okay, plus 2x minus 3. Okay, let's take a look and see what that looks like. Now, you'll recall that when we put x equal to 0, right? What was y? Minus 3, right? Look at that. That goes right through here. That is the y-intercept. As always, like even if it was a line, we would set it. But now, when I set y equal to 0, and I found two factors, right? I found x equals 1 and x equals 3. X equals, remember, plus 3. And when I solved it, do you remember I got an x equals minus 3 and an x equals 1. All right? So a lot of people are going to be doing factoring, and they come up to me, why do we have to factor? Well, one of the main reasons is that in physics problems, in science problems, these have an actual meaning in terms of the way a body falls in gravity or a chemical reaction. Oftentimes, they're going to be a parabolic curve, or any kind of other kind of curve, and you want to discover it, you have to find ways of setting y equal to 0 and getting these points. It becomes not so trivial. So the reason I sent I set up this whole thing was to show you ahead of time. I'm hoping that if you can do this on the final, basically, that you will be able to, I can give you a curve, and not only that, I can give you a second curve. So when the curves cross, you can find where they meet by setting the two curves equal to each other. And that also could be a solution to a word problem that involves curves, like in economics. A lot of times it's curves. It's not necessarily, linear model doesn't necessarily realistically model all processes. Linear models can be good. But depending how the data lays out, this might be a better fit. So then let's just go back to the idea of practicing now of how to factor. You see, I jumped ahead just to show you where I'm going. So if we go to 365, we learned about actually we can go to 367. I know a lot of you have seen this, but at the bottom it says objective 3, if you have your book at 367. It talks about this method of FOIL, which is just those two horns that I drew. First you multiply the x times the x, then you multiply the x times the 5, then the 3 times the x, and the 3 times the 5. Now, when we FOIL it, we're actually not factoring, are we? We're actually going backwards. We're actually distributing. But we end up being able to go both ways. So that's the foiling part. And so I guess we should try one. If you look at example 7 on page 369, okay? So now the main thing is that you got an idea of why we'll be factoring. We factor, we set y equal to 0, and we factor y to find all the x-intercepts. Okay. Ah, it's still there. Remember it? Look, here's the y-intercept minus 3. There was the x-intercepts. You couldn't do it without factoring this guy equal to 0. Any questions about that? It is kind of well, at least you know why we want what we'll be factoring. We'll be factoring because we'll be set up to find these individual factors to find the x-intercepts. So let's see. So let's clear. And then why don't somebody, let's see. Let's do the same problem. It's the one on, well, let's do A. Somebody go ahead and read that to me.
Parentheses, 2k plus 5y, parentheses, other parentheses, k plus 3y, and parentheses.
Okay, so now foil is nothing but those two horns that one's like regular size and one's atrophied like it didn't get enough food. See, this is a nice big healthy horn. This one here is sort of a runt, kind of a horn. And so I hope you know that 2k times k is going to be 2k squared, right? And now I go to the second part of the horn, and that's going to be plus 6ky. You see? I multiplied that times that. Then the inner horn, you can see that that's going to be 5ky. And finally, that's going to be 15y, 2 copies of y, because it's y times y. Now, all we have to do is combine terms. You can see these two are the same. They're both ky animals. Here I deposited 6 ky animals, and over here I deposited another 5k animals. How many have I? How many ky animals? 11. So I have 2 k squared. Maybe 2k squared. Well, okay, so it's 2k squared, and this is going to be a plus 11, right? ky, true? And then plus 15y squared, right? Now, you can see what we did. I just took it. Now, suppose I gave you a test question, and I changed that k to an x. Well, no, I will leave it like that for now. Anyhow, the idea is that I can give you this equation and ask you to turn it into this. Or I can give you this and ask you to turn it back into this. Okay? Now, if I set this equal to 0, let's say, then I want to know how to factor this. Okay, so this is a little bit more advanced factoring because I'm going to have something like this. It's still going to be, I'm still trying to make factors, right? That's equal to 0, right? And then if I can do that, then I know each one of these is going to have to be equal to 0. So I look at my factors here. First of all, when you have a plus sign on the back here, at the very back of a trinomial, it's going to be automatically duplicate the sign in front. So this is going to be plus plus. That's the rule. If there's a minus back there, it's going to be plus minus. If it's a plus here, you duplicate whatever sign's up here. Did you get that? If there's a plus in the back of 3 terms, then you're just going to duplicate here. You're going to put 1 plus sign here and 1 plus sign there. If you have a minus back here, it doesn't care what's in front. It's automatically plus minus. Okay? Now clearly I need to get a k here, right? And a k here. Otherwise I will never get a k squared back. And then I have to have a y here. Do you see a y here? All right. Anyway, by following this technique, I should be able to get back to this. Now, how would I do that? Well, I look at 2, and I look at all the factors of 2. And the only way you can write 2 is 1 times 2. There's no other really way to do it. So it's a prime number. But now I have to look at 15. How many ways can I write 15? Well, 1 times 15, right? And 3 times 5, correct? Is that correct? And I noticed, because this is factors of what? This 2. And this is factors of the 15. Okay, what happens here? If I take 2 times 3, what do I get? 6. And if I take 1 times 5, what do I get? 5, yeah? And if I add those 2 middle terms, guess what? It adds up to this middle term in the middle. So I know that I will not be using these guys, right? And I know I have to have a 2, right? So I've used this 2, yeah? And that 2 has to get multiplied by a 3, you see? So I have to put a 3 here. Or I put it over by the way. No, I have to put it by, sorry. Let me go back. That doesn't go there. Yeah, I'm going to have a 3 over here. See? So now I've chopped off the 2, and I've chopped off the 3. So I need the 1 and a 5, right? So if I put the 5 here, obviously, right? And then I have what left to put, the 1. Do you see that? This is this, and we already proved that, you know. This is already a little bit advanced because I'm throwing, you know, how to find factors when you have numbers other than 1 in front. We'll get there. I'm just showing you that what they gave us in the problem to FOIL will be later on given to you in this format and set equal to 0, and you have to go back to here. I don't know if that makes any sense or not. But we'll plug it forward until it makes sense. Okay, so let's learn some tricks of factoring. What's the reverse of factoring, anybody? So over here we have factoring. Right, so let's see, so I factor. When I factor, okay, I go to these 2 factors. When I multiply my factors back in, you're really the opposite of factoring. The opposite of that will be distributing. A really simple example of that is if you have 2x squared plus 6x minus 4, right? I mean, you could just factor out a 2, right? So you could have just x squared, right? Because I took out a 2. And now I have plus 3x. And then I have minus 2, right? Do you see that? And then, so anyway, if you put the 2 back in, that's distributing back through. FOIL is actually distributing it back the way it was before you broke it up into factors. So factors, you go this way to get back to the original equation, or you go this way to put it into 2 factors. This one has not been put into 2 factors yet because I was looking to see if I can factor this. And it's a problem because if I have minus, it's plus minus, right? So I have to have an x and an x, true? to get back x squared, but the problem is the factors of 2. I'm not worried about factors here because it's just 1, but factors of 2 are 1 times 2, right? And the only way that can come to the middle term is if you add them. So that's a problem, right? Because if I put, let's see, because I put a 1 and a 2, you can see that I'm going to have x squared plus 2x plus x minus 2. Do you see that? X times, now this is factoring, but to go back, that's going to be distributing. X squared minus 2x, right? So you can see this is, there's a problem there, right? See, because that's plus x. And then that's going to be plus 2. So it doesn't work. This particular guy is a problem because we don't have factors. We need factors of 2 that subtract out to be 3, and that will never happen. Now, does that mean I can't solve that problem? No, it doesn't. There's a way we can force it to work. But the ones I've been giving you lately, the ones you'll be receiving, will be able to be broken up to this. You're going to get easy problems. But most problems in real life, they will not factor easily. They will not be nice numbers. Is there a way of solving it? Yeah, there is. There's a quadratic equation that will solve it. And I will derive that for you, but not now, because it will blow your mind. And you'll say, oh, I can't do it. So let's just start practicing. Now, why is this called distribution here with this horn? Because look at it like this. Suppose that x plus 1, forget the 2 for now. Suppose x plus 1 is dinosaur. And now what do I have left here? X minus 2. Do you see that? I'm just calling this whole term dinosaur, just so you'll step back and look at it as a different entity. Yeah? Now, how do I distribute it? With the horn. Correct? That's how you would distribute a dinosaur. So really I have x, right, times dinosaur minus 2 times dinosaur, right? Somebody say right. But I know what dinosaur is. It has a new name. So really what do I have? X. And what's dinosaur equal to? This is dinosaur. What is that? Yes, x plus 1 minus 2 times x plus 1. What did I do? I just distributed this guy to the x, and I distributed this guy to the 2. You see it? And is it going to work? Yeah, because you're going to have x squared minus the same thing as FOIL. Yeah? But another way you can think of it, instead of foiling, is just taking this term and multiplying it times the x, taking this term and multiplying it times the minus 2. And then carry out your algebra. Okay, so now we're just learning techniques of factoring. How do we get back? We distribute. It's the opposite of factoring. Okay, so let's try this other one then. How about if we have this, it's called a binomial. Suppose I have x plus y squared. Okay, now, that's already kind of factored for us, because what does that 2 mean? It means 2 packages of what? Of this whole thing. It means cha-ching, oops, plus y. It doesn't look good. What it means is 2 copies of x plus y. It means x plus y times x plus y. That's what that means. It's 2 copies of that. You make 2 copies in the copy machine. Now, if we go ahead and FOIL that out, that actually goes over to here, right? And this goes to here, and then this goes to here, and that goes to here. Notice that x times x is going to be 2 copies of x. Do you see it? then x plus y is going to be x times y. And this guy, y times x, is going to be another x times y. You see? And this guy here is going to be what? Y squared, correct? Combining your animals, I have 2x squared. So, x squared plus 2xy plus y squared. That's equal to this. I can bring it down. Okay? So, that's okay. And you got to just notice how that goes 1, 2, 1. I mean, as far as the coefficient, there's a 1 in front, 2 and a 1. What if I had this? X plus y to the third power. That means I have 3 Qings. Are you with me? I have 3 Qings of this, right? Somebody say yeah. Yep. So notice, I have x plus y, and then what do I have? An x plus y times an x plus phi. I have 3 x plus y's. I have 3 copies of x plus y. You see it? But look, this one here is another x plus y times another x plus y. But look, we already solved for 2 of them. You see, we already did it. Guess what? 2 of these equals what? This. So what do I have? I have this thing, which I usually call like dinosaur by itself. And I have this that now can be written as x squared plus 2xy plus y squared. See? I just replaced this with what we solved earlier. Okay? So guess what I'm going to do? Well, I can do a triple thick horn, or I can take this whole chunk and distribute it. Does anybody know what I'm talking about? Okay. So let's try it. So I can do a triple thick horn. I can go like this, like this, like this, and I can go like this, and like this. Well, guess what? X times x squared is going to be 3 copies of x. And what is this? Well, that's going to be plus 2 with 2 copies of x times y. And this is going to be plus an xy squared. Do you see it? Does somebody see that? Okay. So how about the bottom guy? Well, guess what that is? That's going to be an x squared y. Do you see it? And that was x. Okay, so now I'm here. This is supposed to be y. Y times x squared. There it is. Now I can take y plus this. What do I have? I have 2x, and I have 2 copies of y. See it? And finally, I have y times 2 copies of y. Guess what that is? That's 3 copies of y. This is a 2. That's a 2. Okay, now what do? I combine my animals. Do I have any animals? Yeah. Let's see. Well, here, look. I have an x squared y animal here, and I have a x squared y animal here. And how about this? Do I have an x squared y animal? I do. And here I have another x squared y animal, 2 of them. Is it 2? That would be this guy, that. That's y, that's xy squared, yeah. There's 2 xy squared, and then I have y cubed. Oh, but look, this is, and this term goes together, right? And there is no other y cubed, right? So let's combine terms. What do I have? I have x cubed. That hasn't gone away. How about here? I have 2 x squared y animals, and over here I have an x squared y animal. So how many x squared y animals have I? 3? 3 x squared y animals, yeah? How about this animal, the xy squareds? Well, I got one here and two there. You see it? So I have another what? Plus 3 x y squared animals? Yeah, those are xy squared animals. And then what do I have last? Plus what? Y to the what? See it? Now, notice something here. This is kind of weird, but notice that we did this to the second power. It was quite a bit of work, right? But to the third power, it's even more work, right? So let me put above this one. Look what happens. This guy here. Let me write it right above there so you can keep count. But watch this. Some guy named Pascal, which is the father of probability theory, started gambling, the whole mathematics of it. So when I had this guy here, this was equal to x plus y, yes, 3 copies. And what was x plus y 2 copies equal to? Well, it was equal to, right, we have right here, right, x squared, right, plus 2xy, right, plus y squared. You can see that this one's bigger because we had triple. Okay, here's Pascal's triangle, which is kind of weird. If you want to figure out what these coefficients are, look at how it's getting bigger and bigger. So if we had before that, suppose I had just this, x plus y to the 1 power. What is x plus y to the 1 power? It's just itself, right? It's 1 copy, correct? So look, I'm going to put it right above here. Notice that this is x, just x plus y raised to the 1 power. That's this. This is x plus y raised to the 2 power. And this is xy. You all right? Are you with me? Okay, now watch what happens here with Pascal's triangle. This guy was genius. He said, hey, I got an idea. He said, how about if I do this? I'll make a triangle. Like, he'll go 1, 1, 1, 1, 2, 2, 1. And then, so you can think of 1 and 1 as 2, and 1 and 1 is 2. Now I have 1, 3, 3, 1. So if you see what I'm doing, I'm just changing up by 1 and 1 is 2, 1 and 2 is 3, 1 and 2 is 3. You see it? And so if you can kind of figure, the next step would be something like, well, 1 and 1, let's say we have 1, then we'll have, let's say 1 and 1 is 1, so now we have 1 and 2 is 3, so now I'm going to have 1 and 3 be like 4, right? And then over here I'll have 4, and then I'll have 1, and then here I'll have, so I have 1 and 1 is 3, so I could have here 2 and 3 is like 5. So look what's happening. So it looks like that notice that this is a 1, 1. Here it is, 1, 1. And this guy, I'm talking about the number in front of the coefficient. 1, 2, wait, I got this wrong. Okay, that's why. So this guy's not 4 terms, it's just 3 terms. There. Okay. So, so then this guy's wrong. So this is 5. So that's 1 and 1 is 3 is 4. 1 and 3 is 4, actually, that's okay. 4. Yeah, and then here I got 3 and 3 would be 6. And here I got 4. And here I have 6. Okay, now, there's a trick now. Instead of doing all the multiplication, you can just use your triangle and say x plus y, put to any power you want. Then just keep extending this triangle. And let's say you now would like to go to the 4th. X plus y to the 4th. Oh, well that's this row. So it should be something like x to the 4th plus 4 times xy plus 6 times, or x squared, what would that be? That would be x, that's x to the 4th, this would be x to the 3rd. This would be 5x squared y to the 2nd. This would be plus 4 times x y cubed. Right, that would be this guy. And then finally, your last term would be what? Y to the 4th power. It's kind of cool because these end up being, this triangle ends up being the answers to any one of these binomials. You don't need to do that. I just thought it was pretty cool. And these have some properties called the golden ratio, which is what's used in architecture and art. But anyway, I don't want to confuse you. So what's the main purpose here? Well, it was just a trick to show you how to look for factors of this. If you have something like this, x plus y squared, you know that in the end that's going to be x squared, right? Plus 2 times xy, the middle term, plus y squared, okay? Now, that's one thing you can actually work it out by making 2 copies and foiling, right? Well, then we have another thing that's called the difference of 2 squares. Now, this is a square minus a square. So we call this the difference of squares. Okay? So guess what we're looking to do? Yes, we want to put it into 2 factors. Well, we know we have to have an x and an x, right? Because we'll never get back to x squared. And if there's a minus, remember it always automatically plus minus. Right? Well, there's no choice. This has to be y and a y. Okay? So difference of squares can always be factored to this. And anything that looks like this, where you have plus minus, with the same variables, can be brought back, distributed that through to be brought back to the difference of squares. Now, is it true? Well, you can test it out, right? X times x. That's 2 copies of x, right? And this is minus xy. And this is plus xy, you see? And this finally is going to be minus y squared. Right? That looks weird. But notice that these 2 terms subtract out, and we get back to where we were. This is important because it's one of the major factoring things called the difference of 2 squares. So suppose I give you this. I have you 16x squared minus 4y. Well, I mean, you could actually take a 4 out, right? But let's see. Let me make this a 9. This is a 9. Okay, this is y squared. Okay, using this idea, first of all, do we have a difference of squares? It looks like we do. But suppose I can write, notice that I can write 14 as 4 squared, x squared, plus 3, no, minus what? 3 squared, y squared. Do you see that? Somebody say they see it. I just changed 9 to 3 squared, which is still 9. I am that I am. So how about if I package it up like this? Now I have 4x squared minus 3y squared, right? Because this, 2 packages of this is 2 packages of 4 and 2 packages of x. Okay? I just put it so that I have this glob, right, this left fist raised to the second power and my right fist raised to the second power. Well, that looks like a lot like this, x squared minus y squared. Except right now, x squared would be this whole thing and y squared would be all this. So you can write it like this right off the bat, right? A 4x here and a 4x here, because this is the only way you're going to get 2 copies back of 4x. And with a minus, you have to have a plus and a minus, right? And so, what's left? Well, a 3y here and a 3y here. Because 2 copies of 3y. Are we worried about a middle term? We're not, because what happens with the difference of squares is they'll subtract out. If you look at this, this is 2 copies of 4x. Then we have minus 12 xy, but here we have a plus 12xy. And now we have plus minus 9, 2 copies of 9y squared. Did you see the trick? The trick was to put the coefficients in terms of squares too. I'm still using this, the same pattern though. Let's try so that's the all-important difference. So you have to practice these foiling. I don't know if you want me to do one of these. Let's do one on the homework. It's every third odd one, right? So now I don't know. So the first odd one would be 1. And then we'd skip 3, and we go to 9, 9. And then we go to 11, and I skip that. And I go to 13. And then 15 I skip. 17. Let's do, these are all pretty easy. I'm trying to find a challenging. Well, let's do one with, wow, look at page 376. Look at number 53. That's 3r minus 2t raised to the 4 power. Guess what? We have 4 copies of that, which we have to multiply all together. That doesn't look so much fun, although we might be able to use, well, anyway. All of those where it says find the product, and you'll see from number 43 to number 54, those are all copies of each one that you have to multiply together. Okay. So let's try example 4 on page 380. Okay, do you see what I want to do? I take a polynomial. It's a big one. It's 180 x to the 4th power y to the 10th power minus 150 x to the 3rd y. And what does it want me to do? It wants me to divide that by what? By 30 xy squared. And you can see it's pretty easy because it has a common denominator, doesn't it? Somebody say it does. You see it? It's a common denominator is what? 30xy. So that means you can distribute it underneath each term. Does anybody know what I'm talking about? Do I have to write it or do you get it? Do you see that the 30xy squared can be written under every term of the equation? You'll see the third line down, 180 x to the 4th y to the 10th divided by 30 to the y. You see it? And when you divide out, guess what you get? You get that. That means that polynomial divided by 30xy gives you an answer of 6x cubed y to the 8th minus 5x squared y to the 6th plus xy to the 4th minus 3y with a remainder of, we had literally divided that out with 10 over 3x.
It looks like they just subtracted the exponents.
They subtracted it from what?
Like on the first one, it's x to the 4th, and then y to the 10th, and then underneath it's xy squared. So it looks like they subtracted x to the 4th.
Well, yeah, that's because, let's see, so in general, you have how many x's on top? So there's just that one term you're talking about.
Okay, it was like x to the 4th,
X to the 4th,
y to the 10th.
y to the 10th,
Yeah.
and then,
Divided by x, y squared.
okay. So how many copies of x do I have? Up top.
4,
That's cha-ching, cha-ching, cha-ching. How about y?
10.
Ching, 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 I think, over what? X times how many copies of y? Guess what? X goes into x. Oh, guess what? That's 3 copies.
Okay.
Guess what goes into there? How many copies of y do I have left?
Okay,
8. Okay? In general, you can think of, this is nothing more than copies. We have 10 copies here and 2 down here. It looks like they're subtracting it, right? In fact, they are, because when you have the following definition. If you move this variable up, the sign changes. So really what you have, you can think of that as y, bring it up here to the minus 2. So in that sense, so if I have x, right, let's say x squared, and now I have x cubed. How many copies of x do I have? Not all at once. How many?
5.
5 copies of x, correct? But if I have this, let's say 3, and now I have times x to the minus 2, well, that's going to be just x. So look what happens here. You can take 2 copies and 3 copies and count them all up and say there's 5 copies. Or more generally, you should know the rule that x raised to the a power times the same base x raised to the b power is in fact equal to x of a plus b. You see it? It's 2 copies here, 3 copies, yes? So this 2 would be equal to x plus 3 minus 1, which is equal to just x to the 1 power, right? What I'm telling you here is that you can manipulate these guys up and down, but the power changes sign. So I can push that x up because there are no plus signs here. So I can write this as x to the 4th times x times, right? So I can write that as x to the 4th times what? X to the minus 1 times y to the 10th times y to the minus 2. Notice that these things got pushed up. You can go up and down like that as long as there's no plus signs in between them. And the sign changes. So guess what this one is on top? That's just x to the 4 minus 1 times y is 10 to the minus 2. And that's why you have x to the 3, y to the 8. I mean, I don't want to complicate it. Basically, it's 10 copies and you're dividing out. Now, I want you should know this because it's just going to make life easier. That if x is same here and same here, then you can add their bases. What about this? If I have x to the a and then that whole quantity raised to the b, what's that equal to? Well, let's try it. Suppose I have x 2 copies and I raise it to the 3 copies. What does this 3 mean? It means 3 copies of cha-ching, cha-ching, cha-ching. How many copies is that total of x? If I have 2 copies, 2 copies, and 2 copies, how many copies of x do I have? 6. What was the shortcut? When you have power to the power, they multiplied. So what do I have? I have x is a times b. Notice, it's not a plus b. A plus b because we're multiplying 2 x's with the same base. This is power raised to the power. When a power is raised to the power, you multiply the exponents. When it's base times a power and base times the same base times the power, it's just adding of the coefficient of the powers. Any question? This thing we need to know. I thought I might have gone over it, but maybe I didn't. Does anybody remember? Is it familiar or no? Not familiar? Well, that was the whole. There should have been a lecture on powers, like in general.
Yeah, there was.
Okay. So here we go. So let's do a division. How about 381? Example number 5. Okay. Can somebody read me that one?
So it's divide 5x plus 4x.
5x plus 4x?
5x plus 4x to the 3rd power.
Like this?
Yep. Minus 8 minus 4x squared. And that's over 2x minus 1.
Okay. Now, the first thing you have to do is figure out which one's going to go in the division box. Okay, remember when we have, yeah, the top one. So I'm going to put a division box here. Okay, but I'm going to order these by the highest powers, right? So what do I have first? 4x to the 3rd power. You see it? The next would be minus 4x to the, yeah, and then, yeah, and then minus 8, right? And then I put here 2x. Okay, here we go. Let's do the division. Now, the first thing I do is I ask myself, what do I have to multiply 2x by to get 4x to the cube? What do I have to multiply 2x by? Well, what do I have to multiply 2 to get 4? 2. What do I have to multiply x by to get to x cubed? 3. If I have 2x here, and I want to multiply it times something in order to get 4x to the 3 powers.
2x squared.
Yes. Right? So the answer is, in order to do that, I have to do a 2x squared. Now, because that's an x squared, you're going to have to put that 2x above this x squared. See it? Not here, but here. So what do I do now? I use the horn. What's 2x squared plus 2x? Well, we just said what it was. It's 4. I did that on purpose, by design. How about this one? That's going to be minus 2x squared. Do you see it? Now, when I do division, I subtract, right? So look what happens when I subtract. Be careful, because I'm going to take this and I'm going to subtract this whole quantity, so I put a negative sign here. That negative sign is going to have to distribute, because I'm subtracting. Then I'm going to subtract. So when I distribute this negative through to here and here, the end result is that the signs are going to change. The end result is that this is going to be minus 4x, and this is going to be plus. Do you see it? Because I'm distributing like a negative 1 into there. So now that I distribute it, I don't need this. I really don't even need this. And you'll just do it by memory. You'll know that you're subtracting. So before you subtract, you must change your signs and then add. So now let's add. Guess what? We did that on purpose, so that'd be 0. But now I spent 4x squared, but I deposited 2x. That's right, negative 2x squared, right? And you bring this down. You see, I just brought it down. Now, I ask myself, what do I have to multiply 2x to get minus 2x squared? What do I have to multiply? Well, we already got the 2, so what do I have to multiply the x by? Yeah, and a minus x, because I need a minus 2x. So I'm going to just put a minus x here. Do you see now x times the first term is minus? Yes, and this other one's going to be plus x, right? But remember, these guys, the signs are going to change. So I'm going to get this. Then I'm going to add. Oops, this is minus, was it? Yeah, so this became a plus, right? So what do I have left here? I have 5x, but I subtracted 1. 4x, and then I bring down to minus 8. So now I ask myself, what do I have to multiply 2x to? 2x to get 4x. To what? Not an x, because I would get x squared. Yeah. A plus 2. So what's 2 times x? It is 4x. And 2 times minus 1 is minus 2, right? But since we're subtracting, we're going to have to change the signs and then add. What do I have left here? Yes. So the answer of this thing is it's going to have a remainder, right? So it's going to be, the answer is going to be, right here is going to be equal to, if you take that divided by that, you're going to get that answer there. 2x minus x plus 2. Yeah, with a remainder of minus 6 divided by 2x minus 1. Does anybody see where my remainder came from? It's this guy divided by this guy. I just added it, or subtracted it, whatever. Well, anyway, they came up with a remainder of -6, but I guess on the next page. Yeah, the next page, you'll see it on page 382. If you look kind of like in the middle of the page, it shows what we have, 2x minus x plus 2, They got a plus, but it can be a -6 over 2x minus 1. Now, according to this, if I can take this guy, right? If I take this and I multiply it times this, because if you take this times this, you should get back to this, right? So if I take a term here, if I want to check my answer, here's this plus the remainder, right? And if I multiply that times 2x minus 1, right? You would have to distribute that all the way through and see if it checks out. You would have to, you'd have to go like this, 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 like this. And when you're all done and said, it better come out to be that. I think you got division. It takes some practice, but
Yeah, I think so. Something I can see.
yeah. Okay. Okay, so let's look at number 77, page 386. Is everybody there, page 386, number 77? You see we have a yellow rectangle? Unless you're colorblind, it might be a different color. X squared plus 2, does anybody see it? Okay. So what's the problem asking? What do we want to know? The length of the rectangle. Let's call this length. And let's call this width. And do we know what is width work? Do they tell us what width is equal to?
5x plus 2.
Okay. But more generally, don't we know that the area, which will be squared, right, is going to be equal to length times width? But they tell us what the area is. What is it?
5x cubed plus 7x squared minus 13x minus 6.
Okay, that's the area, and that's equal to what? Well, we know what W is, right? W has a new name. Yeah, so we have length times, what's W? 5x plus 2. Do you see it? It's just algebra, right? Because we want the L by itself, don't we? How do I get the L by itself? This L by itself. What would I divide by? Whatever's not L. What's not L? I think you said the right thing. I mean, this whole thing I don't want. Don't you see? Do you? Because this divides out. Do you see that? Just think of it as like a 3 or something. If I put a 3 in front of the L, you would have told me divide by 3. But that freaked you out because now you're looking at it like a bunch of stuff. Okay? So now I have an equation. What is it? My equation is L is going to be equal to what? 5x cubed plus 7x squared minus 13x minus 6 divided by 5x plus 2. So which one goes in the box? The division box. The top. Look, you got to know that if you have 3 divided by 4, 3 goes in here and 4 goes in here. More generally, A divided by B, right? The top goes in the box. This you have to know. That's all a fraction is a division. So, this one, is it in the right order? Yes, it has x cubed, right? Then it has a squared power, you see? Then it has a 1 power. And then finally it has just a number. That's the kind of order we're looking for. So guess what goes right here? Yes, 5x plus 2. All right, then I asked the question. What do I have to multiply 5x by to get 5x cubed? What do I have to multiply 4x by? 5x, I mean. I want to get x cubed. Well, if I just x, I'll have x squared. I won't have x3. x2, you mean x squared? Yes, I just need to multiply times an x squared. Why? Because x squared times x is 3 copies of x. So that's going to be, are you seeing this? And if I take this, notice I put it right above the x squared. If I take the x squared and multiply it times 2, what do I got? Plus what? 2x squared. Now, I'm about ready to subtract them, but to do that, I have to change the sign of the sign. Sign of the sign? I don't know if that makes sense. I have to change what they were. So this one becomes minus, and that becomes plus, yes? Now let's add them. Well, we did it by design so that this goes to 0, see? That's why we multiplied that times that, so that this term goes to 0.
That's 9x squared.
Yeah. And then what do I bring down? Right. And then I ask myself, what? Oh, this is trickier, huh? What do I have to multiply 5x by to get 9x squared? Oof. Well, how about x? I know I have to multiply by x, right? Yeah. And then how about if I multiplied, like, I'd like to get rid of the 5, so I'm going to multiply times 9 divided by 5. Why? Because if I take this times 9/5, notice the 5s will divide out. Yeah, but I'm asking, I'm saying, look what happens when I take 9/5 x times 5x. Boy, that's just skiing, really. Right? So what do I have on top? 45? Well, wait a minute. I don't need to do 45, do I? Because guess what? I did it by design. Look, 5 divides into 5. So I guess what I get what I want. What do I end up getting? 9x squared. So I have to actually multiply that thing by 9/5 because the 5 will divide with that 5 and leave me the 9 that I want to get rid of. I know, it's cool. It's too cool. So now here I go. And I multiply that times that. I hope you see that I will get, in fact, a 9x squared. This might be kind of ugly because I have 9 times the 2. So now I have 18 fifths, right? X. That's not pretty. Did you see why? Because 9 times 2, you know, this is, I'm just multiplying 2 times the 9. There's the 18. That's kind of ugly. But we're still trying to figure out what the length. So, what do I do at that point? I'll get rid of this. And actually, I don't need this anymore, do I? So, I look at that and I say, all right, now I have to change the sign, right? So now I got minus, plus. So that ends up leaving me what? Minus 13x plus 18 fifths x. I can put that over 1. And I can use the horn, I mean the nose. So I have this over 5, yeah? And then that's 50 and 15. Yeah, so that's minus 65 x. And 1 times 18 is just 18x, isn't it? Does that look right? 1 times 5 is 5. 5 times 13 is minus 65. And now we have 18. So if that were 20, that would be minus, what, 45? But I have to give 2 more, so what is it? Yeah, right. So if that were 20, so I have to take away 45, 47. So I would have minus 47x over 5. That's what all this equals to. So what's my length equal to? It's going to be equal to x squared plus 9x, yeah? And that looks kind of weird because you have a remainder of, well, you can write it as a remainder of if you want. Yeah. It wasn't as pretty as I like, but yeah. So are we at that time, or are we in lab now? Okay. Good luck. Any questions? Is it too easy?
No.
Where are we headed? We're headed to finally figure out the x-intercepts of higher power polynomials. So we have to learn this factoring and division business. It's really another form of factoring, isn't it? Okay.
The whole other part of chapter 5 is just factoring stuff.
Yeah. Okay. Yeah, you too. Bye. How many you want? Huh? Yeah, it's up to you. You want 2, 3, 1, 4? I really don't care. I'm going to go into the midterm, I think. We don't have that much time. So I'll be doing, if I do a thing, I'll be a midterm review. Maybe I think will be the next test. It would just be a review and then final. Unless you want another test, I could surely do it. Oh, you're? I like it when people are good. Let's say here.